Hi everyone, this video is going to help with arithmetic or arithmetic, I don't know, lots of different ways people will say that word, sequences. And it's 9-2 in Algebra 2. So what are these type of sequences? What are they? They are sequences where the difference between each term is a constant. So they're like a linear sequence. So each term, the distance between each term is the same. So let's write that down. So it's the differences between each consecutive. Remember, consecutive means in a row term is constant. So this difference is a common difference. Okay, so they talk a lot about what's the common difference, and we want to make sure we know that. The common difference is has to be constant. I was looking at the settings on here. You can see this just fine. It's a little light when I use pencil, but anyway, so we were talking about recursive and we talked about explicit formulas in general. For arithmetic sequence, a recursive looks like this. You would always are going to say A1 equals whatever A1 equals, okay? And then A to the n is going to equal A to the n minus 1 plus D. D is that common difference. All right, so you're just adding a number on the term before. So this is why we didn't have like a general formula for the last one, is because they weren't all this type of sequence. They could have been what we learn in the next section, which is a geometric sequence, or they could have been none of the above and just a random different kind of sequence here. Okay, so let's look at the explicit in the for a arithmetic sequence. So explicit is going to look like A to the n is equal to A plus n minus 1 times D. I could put it just next to it, and that means times. So what does all of this mean here? Remember, A is just going to be your first term of your sequence. And then we're going to add to it the n minus 1, which is like term 1, you'd go 1 minus 1. If it's term 2, you go 2 minus 1. So n is just that term spot that you're at, which term number, n for number. D is that common difference. So you're going to times it by the difference and then add back the A, which I was thinking I should have probably written that A down. Let's write this out so we can remember that in our notes. So A is that first term. The second term is A plus D. The next term would be A plus 2D. And the next term would be A plus 3D. And then so forth like that. So this is where the idea goes, is if this is the first one here, right? First term, second term, third term, fourth term, I would put in 1 minus 1, which is 0. 0 times the distance gets me back to A. So 2, I would have 2 minus 1, which is 1. 1 times D. So you'd have 1 distance away plus A, and that gets you A plus D. So you can kind of see where they get that formula. So let's write this formula out and let's learn to use it. So my first sequence is 3, 6, 9, 12, 15. So a little bit easier one. So what is the common difference, and is this an arithmetic sequence. So yes or no, and what if it is, what is the distance? So we look, we're going to go up by 3, then up by 3, up by 3, and we could see easily these are the factors of 3, so, or not factors, the multiples of 3, so we can see that it's going up by 3, so yes, it is arithmetic sequence. And the distance is 3, or common difference, not distance, but it is kind of like a distance to me between each one. All right, let's look at another example. What about, let me move this up here so you can see that. It's like backwards, so I'm like moving it the wrong way. Okay, so what about, what if I want to take that same formula and write both the explicit and recursive? Okay, so let's start with the recursive. So if I wrote it for this, we know we're going up by 3 each time. We know a to the 1 equals 3. We always have to write that down with this one. And then we would write it as a to the n is going to equal that term before plus 3. Okay, and then the explicit for the same one would be, okay, we're going to have a to the n, and it's going to equal a, which is 3, plus n minus 1 times our distance of d, which is 3. Now I could simplify out this formula more, and let's do that and just see what it looks like. Just for I think they'll take this on some of them. Some of them they want you to have simplified it. So we would go, and remember this is the term you start with, and this is what we're going up by. They're the same number, so it's a little bit tricky, but we're going to think of this as distributive. So we'd have 3 plus 3 times n is 3n minus 3. And let's see what happens to the 2 3's cancel, so I have 3 to the n, which kind of looks more like what we did in this section before. So this will reduce down to being 3 times n, because I put in 1, I get out 3. Okay, that doesn't always work as pretty. Oh, did I write out another one? I was just trying to think of another sequence, but I think that's, well, for writing the formulas. But let's look at something like this. What if I say, okay, the first term is 100. I don't know the next term. I don't know the next term. And I know this one's 82. How am I going to find term 2 and term 3? What is some logic between this? Well, we know it's going to be going up by the same number each time. So we can think of it as, to get to the 82, I have to take the 100 and I have to add to it 3, 1, 2, 3 of those differences. Okay, and we don't know what the difference is, so we'll solve for that. So we're going to subtract our 100 over, and we better get a negative, right? Because we're going down. From 100 to 82 is going down. And we're going to get negative 18 equals 3d. Divide by 3, and you'd get negative 6 for our d. Now, does that make sense? And what would these terms be? So I take 100, and I subtract 6. So 100 is the first spot. Subtract 6 and I'd get 94. Subtract 6 more and I get 88. Subtract 6 more and I get 82. So it fits our pattern here and worked out. So the good thing about these type of sequences is that difference is the same each step up that you go. So you could use that logic of how that's working to find missing terms in between. You could also use like the average or the mean between two, because it goes up by the same number. So if you would have had something like I don't know, 15, and then I'll just put an X instead of a question mark, and maybe 59. What would be the X term? Oh, it would help if you could see what I just wrote. So if I have 15 comma X comma 59, and then it keeps going on the pattern, what would be that X term? It's going to be the average between the two. And this is the they call it the arithmetic mean. It's just the average of two numbers. I'm not sure why they have a fancy name for it, but we would add the 2 and divide by 2. So 15 and 59. 15 plus 59 is 74. So 74 divided by 2 is 37. All right. X is going to equal 37. All right, so those are kind of my examples for this type of sequence. These ones are nice because they have the same pattern, so this whole section will be similar problems, which I think you'll really enjoy.